What is up, dudes? It is FoxyFan13 here, and welcome back to another video where today we're going to be coming back to our journey into the world of snap circuits. And today we're going to be taking a look at the individual components of Electro-Gadget 200 by EduScience. We're going to go through the advanced troubleshooting procedure. We're going to talk about the parts, what they do, all that stuff. So without further ado, let's get straight into it. So first and foremost, we need something to mount our circuits on. This is where we get into the base grid. Oh, I shouldn't do that because I might break it. So, the base grid, it is a platform for mounting parts and wires. It functions like the printed circuit boards used in most electronic products, like how the walls are used for mounting the electrical wiring in your home. Similar to what we have set up up here. Here, we got a couple wires here. Got another one up there. Although this is not like a circuit board or anything. You might see some of those in like your breaker, pretty much. So next up, we need something to power our circuits. This is where we get into the battery holder, or part number B3. So batteries produce an electrical voltage using a chemical reaction. This voltage can be thought of as electrical pressure pushing electricity through a circuit, just like a pump pushes water through pipes. As you can see, for example, although this is not a water pipe, I don't believe, this is actually a pipe. You can use them. You might see some of those like around your sink. In fact, let's just do a quick jump cut real quick. Alright, as you can see over there, we got some pipes that are used for this particular sink. So as you can see when I turn the sink on, let me just do my camera here. Here. Just like that. So the water is being pushed through the pipes in order to allow for the water to get into the sink. I apologize if it's dark in here. Let me just get some more light in here. There you go. And then if I want to stop, I can just turn it off, and there you go. We'll get some more about what that kind of stuff can do later. But this is electronics, not plumbing. Let's go back to the lab. Anyways, back onto the subject of batteries. This voltage is much lower and much safer than that used in your house wiring, and using more batteries will increase the pressure, therefore more electricity flows. Therefore, as you saw on the little valve on the little lever on my sink, you can see that if I had it like set to lower, not all the way, less water could come out. So that's kind of a real world connection for you there. This battery holder takes 3 AA batteries, which, as always in snap circuits, are not included. You know what? We need some batteries. Duracell. So this battery holder is rated at 4.5 volts because these AA batteries are rated at 1.5 volts each, which brings us to that total. House power usually is like about 120 volts, but this is not AC, this is DC if I'm not mistaken. Correct me if I'm wrong in the comments. It's because I am a dumb foxo. Anyways, so it looks like that we're all set with that. Let's move on. So the first component that we can power using this stuff will bring us to convert electricity into light. This is where we segue into the lamps, or part L4. So light bulbs, which are mounted in these little components here. Let me show you. Let's see if I can focus here. Come on, focus. Yeah, you can see there's a little light fixture inside here. Come on, focus. This is why I need a new camera. Anyways, these light bulbs, such as these, contain a special high resistance wire. When a lot of electricity flows through, this wire will get so hot that it will glow bright. Voltages above this bulb's rating can burn out the wire. And yes, these lamps do not, the lamps as far as I know do not have built-in resistors, therefore they can burn out. So these lamps are rated at 4.5 volts, just like the battery holder. So what I can do here is I can just place the lamp directly across the battery holder. And there you go. That lamp works. Looks like the batteries are starting to get low. Oof. Let's test the other one out. And there you go. And that's how the lamps work. As a total side note, the lamps used to be lamp sockets with light bulbs coming separately. They would come with the sets, though. You'd have to screw in the bulbs. But starting with the 2010 revision, I believe, that's when they started replacing them with just a single piece here. I got this set around the time as these new lamp revisions were made, so pretty good. But although I do wish I had the old ones because I sometimes like the older stuff in snap circuits. Now how about we do something different? We have been able to convert electricity into light, but what if we could convert electricity into sound? Let me move the camera here. This is where we get into the speaker, or part number SP. Well, not really a number, but you know what I mean. So the speaker converts electricity into sound, and it does it by using the energy of a changing electrical signal to create mechanical vibrations using a coil and a magnet. So as you can see back here, you might not be able to see it, but there is a magnet in here, but I'm not going to demonstrate it. The speaker is rated at 8 ohms. These vibrations from the speaker will create variations in air pressure, which will travel across the room. And you hear sound when your ears feel these air pressure variations. So to test the speaker, what I can do is just tap it across battery. Now I cannot place it directly across the battery because it will not work properly. But I can do it. You might not be able to hear it. I don't know if you can hear it. Let me just put it closer to the microphone here. There you go. Now, as you can see in back here, you can see there's some resistors in there, probably to prevent the speaker from burning out. Now, I don't know if you can see it. You can see those little blue things in there. Those are the resistors. So now, what if you wanted to put a part in the circuit, but you don't want to place it across the battery holder? For obvious reasons. This is where we get to wires. But to be more specific, we're going to start out with the jumper wires. Electro-Gadget 200 comes with the most frequent assortment of jumper wires in snap circuits, which are 2, 1 red and 1 black. So these jumper wires make flexible connections for times when using the snap wires, which we'll get to in just a sec, will be difficult. They are also used to make connections off the base grid, such as projects where they use wires. So wires transport or electricity just like pipes are used to transport water. For example, okay, I'll stop with the pipes now. For now, I mean, we'll see. So to test jumper wires here, what I'm going to do is I'm going to connect this one here as per the advanced troubleshooting procedure. So I can just do this. I'll just connect it like that. And if the lamp lights, we should be golden. Awesome. Now let's test the other one. Good. All right. So now we're going to segue into the snap wires. So the snap wires are wires used to connect components. They are used to transport electricity and do not affect circuit performance. And they'll come in different lengths to allow orderly arrangement of connections on the base grid. So in Electro-Gadget 200, you get 4 1-snap wires, which are used as spacers usually. You'll see how they work. 7 2-snap wires, 4 3-snap wires, 1 4-snap wire, 1 5-snap wire, and finally 1 6-snap wire. So in order to test a snap wire, what I'm going to do is I actually forgot to do this. So in order to test a snap wire, what I can do, I'm going to use a 1-snap wire as an example. I'll just place one end of the snap wire here, or just like this in the case of a 1-snap wire, and I'm going to touch this end of the jumper wire to the snap wire, and if the lamp lights, it works. There we go. Now let's test the others. Editing Foxy, do a time lapse of this, please. And now we are done testing the snap wires. So now we're going to segue into something that will allow us to control the projects. This is where we get into the switches. Electro-Gadget 200 has the two most frequent type of switches in snap circuits, the slide switch and the press switch. So switches can connect and disconnect the wires in a circuit. When it's on, it has no effect on circuit performance, and it'll turn on electricity just like a faucet turns on water in a pipe. I am so sorry. So to test the slide switch here, I went ahead and built project number 1, which is electric light and switch. I'm going to set the switch to the on position here, and if the lamp lights, we're good. And ba-blam. Now, in order to test the press switch, I'll just simply swap out the switch here. Now, the press switch, unlike the slide switch, this type of switch is called a momentary switch. So if I'm going to hold down the press switch here. And when I release it, it turns off. Let me test it again. Just like that. So now we're going to test out the next two parts. We got two sets of parts to test in this next phase of the video. So first things first, we're going to talk about the LEDs. Electro-Gadget 200 has two of the most common LEDs found in snap circuits. The red LED are part D1, and the green LED are part D2. LEDs, or light emitting diodes, are special one-way light bulbs. In the forward direction, which is here, as you can see, you might have noticed these markings on here. These are called schematics, and they appear on circuit diagrams. In fact, let's go to the whiteboard. So take a look at this. This is how an LED looks on a schematic diagram. Same for a diode. So, as you can see, the current can only flow through one way. If current flows through this way, it's going to get blocked off, as indicated by that line there. Just thought it's a quick fun fact for you. Let's go back to the work. So, if the electricity flows through and the voltage exceeds a turn-on threshold, which in this case is about 1.5 volts, brightness will then increase. A high current will burn out an LED, so the current must be limited by other components in the circuit, which we'll get to later. However, I should point out that these LEDs have special built-in resistors. At least, as far as I know, both of these LEDs had to be, as far as I know, the red LED in this kit might have one. I am not sure about this one, but resistors are included in most of the circuits anyway, so no worries. Speaking of resistors, we're going to get into them right now. Resistors are very important components in circuits. Electro-Gadget comes with 4, which are rated at as follows: 100 ohms for part R1, 1000 ohms for part R2, 5100 ohms, which is the case for part R3, and 100,000 ohms, which is the case for R5. So these resistors are very unique. They're not like any of the other ones that I have in any Snap Circuits kit. In fact, I don't even know if Snap Circuits ever made these resistors, because again, this is a spin-off set. So normally on Snap Circuits resistors, the resistor would be across the top here, but instead, they're mounted underneath the parts. Alright, as you can see, the little part right there, that's the resistor itself. Anyways, let's talk about what resistors can do. So resistors resist the flow of electricity in a circuit and are used to control or limit the electricity. So increasing circuit resistance will reduce the flow of electricity. So I went ahead and built project number 8, which is light emitting diode. So now the only difference I made here, I modified the circuit and I replaced the LED with the speaker. So if we hear static, the resistor is good. You hear that? Let me move it to the mic here. So the resistor is good. Now we're going to replace the speaker with the red LED. So if the LED lights, we're good. There we go. Let's test the other one. Now we're going to, let's put the red LED in here. So now we're going to test the other two, the R2, the 1000 and 5100 ohm resistors. We'll get to testing the 100,000 ohm resistor in a little bit. So let's replace that resistor with this one here. So now the LED should be dimmer. It's hard to see it on camera. Now let's test the 5100 ohm resistor. Alright, now you should notice it. Now let's test the microphone, or part X1. So the microphone is a 50,000... Oh, whoops, wrong section. So the microphone is actually a resistor that changes in value when changes in air pressure, aka sounds, apply pressure to its surface. Its resistance typically varies from around 1000 ohms in silence to around 10,000 ohms when we blow on it. So we're going to test it in a little bit because we got another part coming up. Let's talk about the photoresistor, or part RP. Not role-playing for you furries out there. So the photoresistor is a light-sensitive resistor. Its value changes from nearly infinite in total darkness when I cover it to about 1,000 ohms when a bright light shines on it, aka my trademark yellow flashlight. To test the microphone, I've went ahead and built Project 13, which is microphone control. So now when I turn on this, the only difference is that I have the microphone mounted on jumper wires, so you can actually see the LED a bit better. So you don't have to see my head, even though I don't want to show my head at all on video. So that way you can see the LED a bit clearer. So what I'm going to do when I turn on the switch here, now watch the LED. So I'm going to turn on the switch now. As you can see, it's a bit dimmer. So now when I blow into the microphone like this, did you see the LED? Now as you can see, the microphone's all fogged up because I blew into it. But did you notice that the LED flickered when I blew into it? Now, what I'm going to do is I'm going to replace the LED with the photoresistor. like this. So now, as you can see, the light is not that is now the LED is not on at all. But if I shine a light on it, as you can see, it lights up. And now if I cover it, the light turns off. That means that the photoresistors works. So for the next part, we're going to take a look at the adjustable resistor, or part RV, not to be confused with the vehicle by the same name. So, the adjustable resistor is a 50,000 ohm resistor, but with a center tap, which is this thing right here, most likely, that can be adjusted between 0 ohms and 50,000 ohms. At the 0 ohm setting, the current must be limited by other components in a circuit. So to test the adjustable resistor, I've went ahead and built Project 14, which is adjustable brightness. So I'm going to turn on the switch here. Now look at the LED; it's very dim. But as I move the lever on the component to the right here, as you can see, its brightness gets brighter, and as I move it to the left, it gets dimmer. So you might have seen a couple of these kinds of devices in your home. Let me know in the comments where you might have seen some of these, because I'm interested to know. And also, this is a trivia question, and if you win, you'll get a heart. You'll get a heart from me in the comments. So now we're gonna talk about transistors. So Electro-Gadget 200 comes with 2 transistors, which are the only 2 types of two of the most common types of transistors in snap circuits: the PNP transistor, part Q1, and the NPN transistor, or part Q2. So let's talk about how these things work. So transistors are components that use small electric currents to control large electric currents, and are used in switching, amplifier, and buffering applications. They are easy to miniaturize, and they're almost always the main building blocks of integrated circuits, including microprocessors and memory circuits in computers. High currents may damage transistors, so the current again must be limited by other components in the circuit. I don't know why Snap Circuits never makes mention of this. They almost never do. Elenco, if you're watching this, please make notes of this. So PNP stands for positive, negative, positive, while NPN stands for negative, positive, negative. So the difference between these two components is that because there are 3 connection points. There is the emitter. So we're gonna take a look at the NPN one first. It looks like so. I'll show you where the connection points are. So there are 2 important parts. There are some. So the vocabulary for transistors is kind of complex, but I'm going to simplify it just for you guys. If I can just find the circuit, the parts that demonstrate them. So there are 3. So look at the NPN transistor here. So there are 3 parts in a transistor. These being the emitter, the base, and the emitter. So the difference between the 2 parts is that for the PNP, for the NPN, and the collector is up here while the emitter is down here. But on the PNP transistor, the locations of the emitter and the collector are swapped. So I'm going to press the press switch here. So if the LED lights, the transistor is good. So the base is the part that's going to use a small electric current, which is going to be resisted by the 5,100 ohm resistor. It is going to go through the base, and then as for the larger current is going to go through the emitter, and then the collector. Let's do it. So we're good. Let's test the PNP one now. Alright, so again, and as you can see, the locations of the parts had to be swapped in order for this to work. So as I press the press switch, the LED lights, so we're good. Some types of electric components can be super miniaturized, allowing many thousands of parts to fill into an area smaller than your fingernail. Like this. I apologize. So these integrated circuits are called integrated circuits, or ICs for short, and are used in everything from simple electronic toys to the most advanced computers. This is where we segue into the only integrated circuit module in Electro-Gadget 200, the recording IC, or part U6. So integrated circuits and snap circuits are actually modules containing specialized memory and sound generation in ICs and other specializing components, such as resistors, capacitors, and transistors. And they're always needed with them. So let's talk about what each snap on this module has a specific function. So let's talk about them right now. This snap here is the power that goes from the batteries into the circuit. This is like the positive thing here. This snap down here is the power to return to the batteries, which just goes back into the batteries. This is the record control. This is the record control input. This is the play control input. This is the output connection. This is the positive microphone input, and this is the negative microphone out control input, which goes back into the module. Alright, so to test the recording IC, I have went ahead and built project number 4, playback and record. So the unique thing about this recording IC I forgot to mention is that this is an earlier version of it. This is not like the 2015 revision or anything. This is the 2010 revision. The unique thing about this recording IC is that it records messages that are 8 seconds long. Normally, on the newer versions of the recording IC, their messages are 5 seconds long. So this is a piece of snap circuit history right here for you. So anyways, what I'm supposed to do in this circuit is I'm going to turn on the slide switch, and then you're going to hear a beep from the speaker signaling that it's going to record me from the microphone. Let's do it. Mic check 1, 2, 3. That means that recording time has expired. Now let's play it back. Now it should play back the message followed by one of 3 pre-recorded songs on here. We're not going to listen. Actually, you know what? Forget it. We're going to listen to them. Let's go. Mic check 1, 2, 3. And just like that, it works. If you can identify this song for me, please tell me in the comments. Alright, let's press it again. It'll play back the message again, and it's going to play a different song. Mic check 1, 2, 3. And now for song number 3. Mic check 1, 2, 3. and that is the recording IC. Talk about the whistle chip, or part WC. Don't worry, Microsoft Mary, it's not that kind of WC. Anyways, the whistle chip contains two thin plates, which you can see on the bottom here. You can see one of them, or two of them, I'm not 100% sure. But anyways, when an electrical signal is applied across them, they will stretch slightly in an effort to separate, like two magnets repelling each other. And when the signal is removed, they come back together. If the electrical signals applied across them is changing quickly enough, the plates will vibrate, and the vibrations create variations in air pressure that your ears will feel, just like the sound from a speaker. Alright, so to test the whistle chip, I have built project number 161, which is LED music. So I'm going to turn on the switch here, and I'm going to press the press switch, and it should play a song from the recording IC through the whistle chip. Now it's going to be very quiet, but that is normal for this particular component. If you can't hear it, I'll do it right. Oops. Oh, frick. Alright, let's try that again. You can hear it, right? So please note that in the previous projects, which are in this one and the last one that we did, the lamps are being used to limit the current through the transistor. They don't usually light, although I actually have seen them do it at times, but very, very dimly. Alright, that's the whistle chip. So for the final three parts of this set, we have capacitors. So Electro-Gadget 200 has three capacitors, which are 0.1 microfarads, or C2, 10 microfarads, which is part C3, and 100 microfarads, or part C4, not the explosive. So capacitors are components that can store electrical pressure, voltage, or aka voltage, for periods of time. Higher values have more storage. So in this case, this is the lowest value, and this is the highest value for this particular set. Because of this storage ability, they can block unchanging voltage signals and pass fast-changing voltages. And they are used for filtering, oscillation, and sometimes timer circuits. We'll get to those later. So in addition to this, the whistle chip also acts like a 0.02 microfarad capacitor in addition to its sound properties. So to test two of the capacitors as well as the 100,000 ohm resistor, I went ahead and built project number 116, which is the tone generator. So when I turn on the switch here, we should hear a tone from the speaker and the whistle chip. And that's just like that. Now I'm gonna place the 0.1 microfarad capacitor across the whistle chip, and now the pitch of the tone should be lower. And then there we go. So, okay, so one thing I forgot to point out about these capacitors is that please note that the 0.1 microfarad capacitor is not polarized. These two capacitors are polarized, which means you should never, under any circumstance, connect them backwards. Otherwise, this happens. Yeah, you shouldn't do it. Credit to Electroboom for telling me about what happens if you connect a polarized capacitor in the wrong direction. Anyways, we're gonna put the 10 microfarad capacitor, or with the positive side pointed to the left, across the whistle chip. And now we should hear a clicking sound every few seconds from the speaker. Here we go. Let me put it here so you can hear it. And there we go. So to test the 100 microfarad capacitor, I have built project number 75, which is the auto off night light. So when I turn on the switch here, well, we're going to probably see the LED turn on and then slowly fade out and turn off. Here we go. And watch the LED closely. There you go. Now I'm going to press the press switch, and it should come back on and then turn off. And then just like that. And it's gone. Alright, so that about wraps it up for this Snap Circuits video. Oh, if you enjoyed this video, why not consider giving it a like? And if this happens to be the first video you've seen by me, why not consider subscribing and hitting the bell so you'll never miss an upload. The projects for Electro-Gadget 200 are coming very soon, so do not miss out. With that said, thank you very much for watching, and I'll see you all in the next video. Have fun, stay handsome, peace out.